Thank you very much. Welcome to today's class. And today we are going to look at the Phi coefficients. And I'll start by giving a brief definition of Phi coefficient. Then we will move on to do some calculations. And thereafter, we'll see how we can get the Phi coefficient from the SPSS. Phi coefficients, also called mean square contingency coefficient, is a measure of association between two binary variables. And the formula for getting the Phi coefficient is AD minus BC all over A plus B in a bracket times C plus D in a bracket times A plus C into bracket times B plus D. And from my right hand, my left hand, you can be able to see the symbol for the Phi coefficient. How do you interpret a Phi coefficient? Similar to Pearson correlation coefficient, a Phi coefficient takes only values between -1 and +1. -1 indicates a perfect negative relationship between the two variables, while the negative pi indicates that the variables are inversely related, or when one variable increases, the other decreases. 0 indicates that there is no association between the two variables, and +1 indicates a perfect positive relationship between the two variables. There are some assumptions one makes when using a Phi coefficient, and every statistical method has assumptions. Assumptions mean that your data must satisfy certain properties in order for the statistical method results to be accurate. The assumption for the Phi coefficient include that the two variables must be binary. The two variables that you are using must be binary. What do we mean? The binary means two. So your two variables must be binary, and some other people call them dichotomous. Binary means that variable is categorical with only two possible values. Some good examples of binary variables include gender. When you are using gender, you know you can measure gender either as a male or a female. This is a binary variable. Another one is when you are using a scale to say a respondent says whether it's true or false. Another kind of a dichotomous or binary variable is when somebody is using a scale of yes or no. When we use Phi coefficient in the following scenarios, you want to know, you use the Phi coefficient in the following scenarios. You want to know the relationship between two variables. So the relationship, you want to know the association that is there between the variables. How do the variables associate? The two binary variables, how do they associate? And also, we can also move on to have this, that your variable of interest should be binary, as we have stated earlier, and also the binary, they have only two variables that you are going to consider. Let them not be 4, let them not be 5, that only two variables you are going to consider. When using the pi, when should we use the pi coefficient to check for the relationship or the association between two binary variables? And we have other type of statistical testing that analyzes the differences between variables. And also we have those statistical tests that do predict, do the prediction between the variables. We are not going to consider that right now, but now we are only looking for the association. Now, we have one example here of calculating a pi association. And this one includes gender and political parties. You want to see whether there is an association between gender and the political parties. 25 voters were surveyed and their political parties or preference was noted. And the following results in the table were obtained. So we have 4 males were for the Democratic Party, 9 males were for the Republican Party, 8 female were for the Democratic Party, and 4 female were for the Republican Party. In total, all of them were 25. Now, we want to see step by step of how we can calculate the Phi coefficient manually. First of all, we have to get a grid. And this grid at the top, we have put the parties, Democratic Party and the Republican Party. And on the left side, we have the gender. We have put the male and the female. So we now proceed to name each cell where we have our representatives. So the first cell, we name it A. The second cell, we name it B. The third cell, we name it C. And the fourth cell, we name it D. I'll repeat. That we have a grid that we have drawn. And on this grid, we are able, at the top, we have one variable, and that variable is the political party. So we have Democratic and Republicans. And on the left side, we have another variable. That is the variable for gender. And we are measuring it at male and female. Now, these cells that are inside, we name the first cell A. We name the first cell A. The second cell, we name it B. The third cell, we name it C. And the fourth cell, we name it D. Then we are able to proceed and able to calculate, use the formula we were able to give at the beginning of the lecture. In this grid, we're able to take the diagonals first. So we have the diagonal that is B and C, we multiply it. So we multiply B and C, and also we multiply the diagonal of A and C. And then we are able now to get, this is what go to our new numerator, AD minus BC, as we heard it, AD minus BC. This is what goes to our numerator. Then we have the denominator. The denominator, which is squared, this is how we get it. We have our grid. Now we have A plus B. B. We have C plus D. Then we have B plus D. Then we have A plus C. We have all of them, and you have seen how we have been able to go having all these letters from our grid. Then we're able now to put all the values here in our formula. A plus B, C plus D, P plus D, and then A plus C. All of them having been taken to our formula. We are now able now to have our formula as pi equals to AD minus B, C in our denominator, in our numerator, divided by what goes to our denominator, A plus B bracket, C plus D bracket, A plus C bracket, and B plus D bracket. Then we have from our grid 4 times 4 minus 9 times 8 all over root of 4 plus 9 bracket, 8 plus 4 bracket, 4 plus 8 bracket, a 9 plus 4 bracket. This is the substitution. We are doing the substitution in our formula here. Then we're going to get 16 minus 72 all over the root of 24,336. The answer we go to get as pi is negative 0.3589. How do we interpret the Phi coefficient? The general rule of thumb for correlation coefficients, and you can use them for the Phi coefficient also, is the numbers from -1 to -0.7 indicate that there is strong negative association between the variables. The number from -0.7 to -0.3 means that there is a weak negative association between the variables. Then the number between -0.3 and +0.3, it might indicate that there is little association or there is no association at all. Then the numbers +0.3 to +0.7 means that there is a weak positive association between the variables. Then +7 to +1, +0.7 to +0.1 means that there is a strong positive association. I'll repeat that one. +0.7 to +1, it means that there is a strong positive association between the variables. We can also compute phi constant in the SPSS. Now, in SPSS, you also are required to create 2x2 table by selecting the following. You go to our SPSS, and we had put data in our SPSS the other day when we were putting the data manually. In our last lecture, we were trying to put the data manually, and today I hope that you are able to put the data, and you've completed for the 100 questionnaires which I asked you to do. Then on this program of SPSS, go to analyze. I have indicated where analyze is in the top menu there. And then when you click analyze, you'll be able to go to descriptive statistics. Descriptive statistics. Then from descriptive statistics, when another pull down menu will appear, then you go to crosstabs. You go to analyze, descriptive statistics, then crosstabs. Then from there, you are going to have a dialog box. And in this dialog box, all your variables that you have will come to one of the dialog box in the left. Then you'll have a blank dialog box in the row column there. So we're good to move one of the variables from the populated dialog box. You double click on it, and when you double click, you are able to get the pattern. I'm showing you the pattern there. That pattern there, you are able to get to that pattern. That pattern will transfer your variable from the variable dialog box to the row. Then thereafter, you'll be able to see that the row and column are populated. In this case, I have taken what is your gender from the variable population list, and I have put it in the row, and I've also gone down the population list and have put in the opinion of the respondent according to the opinion of the respondent on the performance, whether it was affected by COVID-19 or not. Then I got to statistics. Go to statistics. Go to statistics. After you have been able to click on statistics, statistics there, it will give us another dialog box. And on that dialog box, we have chi-square up there and correlations. When you go down to nominal, we have contingency coefficient, we have phi or gamma 5, lambda, and certainty coefficient. And when you come to ordinal, we have gamma, summa, Kendall's taushi, and we have also eta at nominal by interval, kappa, risk, and others down there. But we are interested on pi and gamma 5. So we highlighted that, we tick that one, and we tick that one, and we are able now to continue. You continue down there, you continue, click continue, then you are able now to get your results. Your results will come with the nominal by nominal phi and grams 5, which is at 0.214. 0.214. I am not going to deal with the approximate significance there, but in my interest today is at the generating the pi from the SPSS. Then we are able to get it there, and we are able to get those values there, and we have to record them the way they appear and interpret them the way they are supposed to be interpreted. Note, grammar's 5 is useful to tables which are larger than 2 by 2. Remember that we said that phi, we must have 2 dichotomous variables. But if we have a variable that is larger than 2, then we are able to use grammars in order for us to get the value the way we are able to get it in this lesson. Thank you very much. I will be able to give questions for us to do the practice of how we can be able to calculate the Phi coefficient and also be able to calculate from SPSS.